Hello everybody, my name is Philip Matthews and thank you for letting me join your group. Thought you might be interested in seeing what I've done to my laser machine, and just in case it's of any help or use to anybody. So I think we'll start by showing you what I did to the bed. The bed's like a stainless steel sheet, perforated, and I've made two runners on the side to support it, and there's an adjustable screw, you can see it, this black one here, on each of the corners, which means I can tilt the bed to get it exactly level. These screws come in and out quite simply like that, and there's an extra height adjustment on there so I can move the bed up and down. I made some spaces with these. They're like they're just bolts really. They've got a spring. Well, you can see they're self-explanatory really. I can wind the top of that up and down to adjust individually the different things, and I can position them anywhere I want just by popping them in there. The centre up, and then the weight of them holds them down, so that's quite convenient. Just show you how I adjust these little adjuster things and what they're made of. So they're just stainless steel bolts with the head machined down, obviously to fit in there like that. Just adjust them obviously like that with some calipers, which means I can get them all exactly the same. That's quite handy if you've got something that's not even underneath but even on the top, so you can individually adjust everything just to get the top nice and clear. There we go. Get an idea of those things on the corner there. You can see how it works, and it goes in the slots on the two sides of there. Now you might notice I've got a rotary table in the bottom as well. Okay, now I'll show you how the rotary table actually works brilliantly, and it's a solid thing. So the beauty of it is when you bolt it to the actual machine, you get a very rigid square base on which to put the top part, which keeps the whole X and Y nice and level. So you can see that basically I've drilled and tapped it so it's got screws in the corners, as you can see anyway. It fits in, and I'll show you it working later on and how it's connected. I've done a few things to the actual airflow at the head of the laser, which I'll explain in a moment. As you can see, there's no wire, but I do have an LED display on the front of it. I'll show you. Right, it's easy to remove. Might not be easy with one hand, but I'll try. I've made it so that the pipe actually folds around there and holds the whole thing in place. So when I want it off, you just rotate the pipe like that and pull downwards like that, and it comes off. Now this was a great design somebody did on Thingiverse, and it's got a hole in there which puts air across the laser and keeps the smoke off it, which I thought was a really brilliant idea. And then I added a bit on for a line laser. Well, it's not a line laser, it's just one of those little laser things you get with the Arduinos on there. And I thought, well, why not make the wire go up the pipe? So that goes up the pipe into the back of the machine, and then everything's really neat. Okay, you can see where sometimes things went wrong, like where you can see where the pipe's burnt and that, but that was just while I was experimenting. That doesn't happen now. Right, so I've put that back on now, and then I can just hold it in place by adjusting this. Just tilt it like that so it just rests against the top of the mirror, and then it's nice and solid and on without putting too much force on. The pipe itself is a couple of little brackets here, and I find it doesn't get in the way anymore. It's great. It just flexes like that. Okay, no. In the lid, installed two fans, intakes on 3D printed mounts in the front to keep them nice and neat. That works very. Don't know if you can see the white plate underneath the stepper there, but that's a support for the actual ribbon cable, because I didn't like the way it was flapping about, so it keeps it nice. Right, this is my panel I did for the machine, which has the flow meter on, which I'll tell you about later. I'll show you that working in a moment. This is the wiring inside the machine. Go. I've got a separate power supply there to power the fans, and also the stepper driver for the rotary table, which is there. There's an Arduino relay down there that controls the air pump off and on. that's the air pump, variable power supply, and the air pump itself. And I took the connector off the original board that was in here, soldered onto a bit of Veraboard, and this is an Arduino R3 with the shield, the CNC shield, and 3 I think the other 5 something steppers, I can't remember what the number is, stepper drivers, and it all works very well actually, so quite pleased with that. And there's a MOSFET there for turning the laser off and on. Okay. Right, a view from around the back. There's a 3D printed adapter there, and I put a fan in there to assist on obviously extracting the fumes, but don't rely on that. It's just an assist. It actually goes into the wall there through that tube, which obviously I've disconnected, through the wall, up, and then out up there. And there's an extractor fan actually at the outlet, which is the proper place to put it really. It works extremely. Inside these are 3D printed brackets for the mounting the laser tube. There's just a little bit of self-amalgamating tape there, just so it create a bit of friction, and it doesn't need to be clamped tight, so I said I put some bands over there to hold it down. But it's quite nice because you can just adjust it by these up and down and the angle and backwards and forwards and get it exactly right. You notice it's a 10 tech high tube because I blew the tube up when the floor, accidentally forgot to put the floor on, or something happened to the floor and just went bang. But I recommend these tubes, they're excellent. I had no problem. Rewired the sockets at the back, don't use them without rewiring them, and obviously the earth thing, good scrape and good earth connection. That's the connections for the flow sensor, and they're the temperature sensors, which obviously butt up against the pipes and give me the laser in and out temperatures. And a little connection there, and the tubes go down through a hole and end up with the water cooling vessel underneath the reservoir. Right, this is what I do. Run through the procedure and show you the panel. First thing I do is check I've got laser temperatures okay, and I've got flow on there. Everything's alright there. First one is the light for the thing, off and on. Next one is the guidance laser down there. Extractor fan, and the air pump back. If it's at the top, it works by the G code, i.e. the program will switch on. If I put it down there and have manual and hear it running there, and control the flow with that. It's quite useful at times. So I'll put it back on the G code. And the last one is the laser enable. If I enable that, there's a flashing light there. It tells me that the laser is actually active if I was to run the program. Okay then, this is my program. I'd love to use this program, Lightburn. I think it's absolutely amazing. I particularly like this, where you can adjust the horizontal space. I don't know if you can see that on the laser, and watch it like welds it together, so it's just brilliant. Quick check it's all level, just place it on the different parts, move around, check, check, check. Now my preferred way of working is just to set the laser where I want it by hand. So set start from current position, I hope you can see that, and the job origin is down the bottom left, which obviously you can put wherever you want. I have 2 macros for the Gerbil, one set stepper to hold and one set stepper to release. Now if I move the stepper after pressing that set stepper to hold, you cannot move the steppers anymore. I'll show you that. I'll just set stepper to hold and move. Okay, just anywhere. There we go. And then if we go to the machine, see it's locked. Okay. Now then, if I set stepper to release on the console instead, there we go. And then you have to move it first, obviously. Doesn't matter where you move it. Now if I go across, you see it moves lovely and easy. And then all I need to do then is put the laser guider on, and there, put the dot wherever I want on there, which I find easier, and it will start from that actual. Right, I've set the outline to red, which gives me 8mm a second and 100% power. The digital display is set to 80% on here. That's equivalent of 10 milliamps because of There's some alterations I did inside. I don't know whether it's of interest to anybody. I was thinking about making something to do it. But basically you can set whatever current you want on the milliammeter for whatever reading you have on the digital meter. In this case I set 10 milliamps for 80, so I could always go to 100 for a little bit more, but really I've never found it necessary to go above 10 milliamps. Right, so we're all set up over here, and then over here. Just position this wherever I want. I know you're not supposed to move it because it's supposed to damage the stepper drivers, but they're only a few quid each, and I know how to change them, so the convenience outweighs that really for me. Plus I've been using this now for about 4 or 5 months doing this, and there's absolutely no problem. Okay, laser armed, we'll just start it off. There we go. And cheated it because I've already tried to make sure it worked. As you can see, it's dropping straight out. Nice clean cut. And this is standard mirrors. I haven't changed the mirrors or anything yet, or the lens. It just basically works. I say it was vastly improved when I put that 10 tech tube in, like. So there we go. I'll switch it off now and show you when it's. Oh yes, just to show how the evacuation's going there. It's flying out. Let's have a look outside. Yeah, there we go. Absolutely throwing it out. So the evacuation works very well through the fans at the front as well. There's the finished article. Back. Oh, that's the front. That's the back. See, there's not much smoke damage, and it's. Oh, you can see that was quite a nice cut. Right, a demo of the obviously the rotary table. It's just a pure fluke this, but if you put in a normal wine bottle in, which I presume is a normal wine bottle, it actually is exactly the right size ready to laser, which wasn't by design, just by accident. So I would show you what lasering, but as you can see by my monitor at the moment, what have I got? 24 in, 23.25 out. It's too hot to switch the laser on, so I'll have to. Now then, checking my monitor there, I can see the temperature's creasing. It's quite a hot day here today, so I might have to stop soon. I don't like really to go over 22 degrees. But I can see the floor and everything's alright. It heats up mainly because this cover's on here and the heat builds up, and if I take the cover off I can keep it cool much longer, which I was thinking about maybe it's putting in some 3D printed enclosures here and some little fans to blow air across the tube. If I try that I'll let you know how. Using light burn for the rotary, you just go in tools, rotary setup. I hope you can see this. It's a roller type, and I've got it set on the Z axis. I've got 3 outputs on the Gerbil controller. I've set it to the Z. Just click OK. Click enable rotary. One thing to remember is if you want to disable the rotary, you have to reboot Lightburn before it'll drop the rotary table out. I'll show you. Just give it a little spray. I don't know if it makes any difference, but I read it does. I haven't tried. Lightburn again, of course, and I'll start it off. Here we go. Right. So it frames it first, and there's a bit. You see the writing appearing. Yeah. Switch it up.